All right, so we've been spending a good bit of time with graphing these polynomials, and one thing we have to do in order to do that is to be able to factor them out. And in order to factor them out, one thing that helps is to know if something's a factor, and in order to do that, we need to be able to divide it. Now, dividing polynomials is a lot like the long division that you did in grade school. And in order to practice that, what we need to do is kind of prime our memories on how we did that. Okay, so just to prod your memory, what I'll do is I'll do a simple version of that. Let's say we have 5,186 divided by 12. Now, I can't just look at those numbers and figure that out right away, but I do know how to do this the long way. 12 into 5,186. 12 does not go into 5, so I look over at 51. It goes into 51 4 times. 4 times 12 is 48. Subtract, we have 3 and an 8. When we go 12 into 38, that goes 3 times. 3 times 12 is 36. Subtract that, we get 2. Carry down the 6. 12 goes into 26 2 times. 2 times 12 is 24. And we have a remainder of 2. So what we wind up with is 432 plus this remainder of 2, which is still divided by 12. Now we could have, of course, simplify that to be 1/6. But what I'm going to do is I'm going to leave that as 2 over 12 just to illustrate that the denominator stays the same. So now that we've done that, let's extend that algorithm a little bit and see what we can do with polynomials. Now, we have to alter that a little bit when we're dividing polynomials, but really surprisingly little. For example, let's say we have x squared plus 8x plus 15 divided by x plus 5. Now you might be able to look at that numerator there, the x squared plus 8x plus 15, factor it out in your head, get x plus 5 times x plus 3. So when we divide these two, we would expect to get x plus 3. Well, let's see what happens. We actually set it up much in the same way. The denominator goes over here, and the numerator goes inside. X squared plus 8x plus 15. Now, this is where things start to differ from long division with numbers. When we are dividing polynomials, this is very, very important, we are only looking at this term right here of our denominator. We're looking at that x, part of our x plus 5. We are not worrying about the 5. The 5 is just kind of along for the ride. What we're going to do is we're going to first look at how x will go into x squared. We'll put the result up here, and then we'll multiply out below. So let's go. X goes into x squared x times. You multiply out, x times x plus 5 is going to be x squared plus 5x. So you take that x and you distribute it into the x plus 5. You want to make sure that your powers, your like powers are all lined up here. So x squared is directly below x squared. 5x is directly below 8x. We subtract. We get 0. 8x minus 5x is 3x. And then we carry down the 15. We do the same thing again. X goes into 3x. How many times? Positive 3. Now we multiply the 3 by everything in our denominator, so we get 3x plus 15. We subtract, no remainder, and lo and behold, our answer is what we'd expect it to be, x plus 3. So scrolling back up, when we divide x squared plus 8x plus 15 divided by x plus 5 is x plus 3. with no remainder. If we multiply this out, what we would get is x plus 5 times x plus 3 is equal to x squared plus 8x plus 15, which is what we would expect from being able to FOIL that out in the first place. So this confirms the technique we're using here. Now, here's what I'm going to do. I'm going to do one more example without all of this, all of the arrows, and I'm going to verbally explain what we're doing, but without all the extra illustration. And I'm also going to up the power a little bit. 4x cubed minus 13x squared minus 2x minus 15 divided by 4x plus 5. Now, unlike the previous example with x plus 5 and x plus 3, I am not looking at that with any inkling of an idea what I'm going to get, at least just from eyeballing it. Well, we do the same thing. 4x plus 5 going into 4x cubed plus 13x squared minus 2x minus 15. We look at the first terms. 4x goes into 4x cubed, x squared times. X squared, we multiply it out. X squared times 4x is 4x cubed plus 5, so plus 5x squared. Now, this is where sometimes people run awry. What we are doing here is we are subtracting. 4x cubed minus 4x cubed is 0. 13x cubed minus 5x cubed is 8x squared. Sorry, x squared. 13x squared minus 5x squared. We carry down the negative 2x. And buy myself a little bit of room here. And we proceed again. 4x goes into 8x squared plus 2x times. 2x times 4x plus 5, 8x squared plus 10x. Subtract 8x squared, we get 0. Negative 2x minus 10x is minus 12x. Carry down the 15 all the way, minus 15. 4x goes into negative 12x minus 3 times. Minus 3 times 4x is negative 12x. Minus 3 times 5 is minus 15. And we get 0 remainder again. So we get x squared plus 2x minus 3. Okay. So that's helpful. Now, that does not always mean that when we divide polynomials, we're going to get no remainder. In fact, oftentimes we do get a remainder. Here's an example of what we do when we get a remainder. Let's say I want to divide 2x cubed plus x squared minus 4x minus 3. Divide into that x minus 1. Setup is exactly the same. X minus 1, 2x cubed plus x squared minus 4x minus 3. All right, x goes into 2x squared, or sorry, 2x cubed. It goes in 2x squared times. 2x squared times x is 2x cubed. 2x squared times negative 1 is minus 2x squared. 0, x squared minus negative 2x squared is 3x squared. Drag down the negative 4x. X goes into 3x squared plus 3x times. 3x times x is 3x squared. 3x times negative 1 is minus 3x. Negative 4x minus negative 3x is going to be negative x. Drag down the negative 3. X goes into negative x minus 1 times. Negative 1 times x is minus x. Negative 1 times negative 1 is plus 1. Negative 3 minus 1 is negative 4. So, alas, we have a remainder here. when we divide, we get 2x squared plus 3x minus 1, and then we're left with minus 4. And as in our earlier remainders, that 4 is still being divided by our denominator, x minus 1. We finally have one more thing we need to look out for. That is this. What do we do if we have some missing terms? For example, all of our earlier examples have had a polynomial that we are dividing into of descending terms. We've had an x cubed term, x squared, x to the 1, and then our constant term. But what if we have this? What if we have x squared minus 9 divided by x plus 3? Now, looking at that numerator, it's a difference of squares. We would expect that to be x minus 3, x plus 3, and the x plus 3's would cancel out, so we expect x minus 3. So we know what we should expect. But for the purposes of this illustration, it does make a nice example here. What we do is we simply rewrite it as x squared plus 0 times x minus 9 over x plus 3. Now we have our descending powers. We just have 0 as a coefficient. So x plus 3 goes into x squared plus 0x minus 9. And we work through exactly as before. X goes into x squared, x times x plus 3 is x squared plus 3x. Subtract 0, 0x minus 3x, negative 3x, carry down the negative 9. X goes into negative 3x, negative 3 times, negative 3 times x plus 3, negative 3x, negative 3 times 3, minus 9, 0, 0, so we have no remainder. We get x minus 3, which is what we expected in the first place, with that difference of squares. So, if we choose to rewrite this as two polynomials multiplied by one another, we have x minus 3 times x plus 3 is equal to x squared minus 9. Now, after you've gotten this into your notes, your practice problems for tonight are going to be on page 364. I'd like you to do numbers 1, 3, and 9. 1, 3, and 9.